Hello, everyone. In our last lesson, we covered the content related to fire water pools, tanks, and pumps. Today, we will continue to learn about fire pressurization, booster facilities, and pump adapters among the commonly used equipment in fire water supply and drainage systems. The function of a pressure stabilizing pump is to ensure that the pipeline network is filled with water and to maintain the pressure within the network. Pressure stabilizing pumps should preferably be centrifugal pumps and should meet the following specifications. 1. It is advisable to use single suction single-stage or single suction multi-stage centrifugal pumps. 2. The material of the main components such as the pump casing and impeller should preferably be stainless steel. The design flow rate of the pressure stabilizing pump should comply with the following regulations. 1. The design flow rate of the pressure stabilizing pump should not be less than the normal leakage volume of the fire water supply system's pipeline network and the automatic startup flow of the system. 2. The normal leakage volume of the fire water supply system's pipeline network should be determined based on factors such as pipe material and joint type. When there is no data available on pipeline leakage, the design flow rate of the pressure stabilizing pump should preferably be calculated as 1% to 3% of the fire water supply design flow rate, and should not be less than 1 liters per second. 3. The automatic startup flow rate of the fire water supply system, which utilizes alarm valve pressure switches and other devices, should be determined based on the product specifications. The design pressure of the pressure stabilizing pump should meet the following requirements. 1. The design pressure of the pressure stabilizing pump should satisfy the requirements for automatic system startup and keeping the pipeline network filled with water. 2. The design pressure of the pressure stabilizing pump should maintain the pressure at the automatic pump startup pressure setting point to be greater than the system's set automatic startup pressure value when in a quasi-operational state, with an increase of preferably 0.07 megapascals to 0.10 megapascals. 3. The design pressure of the pressure stabilizing pump should maintain the static water pressure at the most disadvantageous point of the water extinguishing facilities in the quasi-operational state to be greater than 0.15 megapascals. Temporary high-pressure fire water supply systems equipped with pressure stabilizing pumps should incorporate technical measures to prevent the frequent startup and shutdown of the pumps. When using a pneumatic water tank, its regulation volume should be determined based on no more than 15 startups per hour for the pressure stabilizing pump, and its effective water storage volume should not be less than 150 liters. The suction pipe of the pressure stabilizing pump should be fitted with a rising stem gate valve, and the discharge pipe should be equipped with a silencing check valve and a rising stem gate valve. There should be a backup pump for the pressure stabilizing pump. The purpose of installing a pneumatic tank is to prevent the frequent startup and shutdown of the pressure stabilizing pump and to provide a certain amount of initial water volume. Pneumatic tanks should preferably be of the diaphragm type, and their adjustable water volume should be determined based on no more than 15 startups per hour for the pressure stabilizing pump, with a minimum of 300 liters for fire hydrant systems and 150 liters for sprinkler systems. Pump adapters are fixedly installed outside buildings and are used for connecting fire trucks or motored pumps to convey fire water and other liquid extinguishing agents to the building's internal fire water supply systems. They can be classified into above-ground, underground, wall-mounted, and multi-purpose types according to their installation form. The following locations should have an indoor fire hydrant water supply system equipped with a fire pump adapter. 1. High-rise civil buildings. 2. Residential buildings with fire water supply, and other multi-story civil buildings exceeding 5 stories. 3. Basements or semi-basements with more than 2 stories or a building area greater than 10,000 square meters, indoor fire hydrants with a design flow rate greater than 10 liters per second for combined peacetime and wartime use in civil air defense projects. 4. High-rise industrial buildings and multi-story industrial buildings exceeding 4 stories. 5. Urban traffic tunnels. The water supply flow rate of the fire pump adapter should preferably be calculated based on each 10 liters per second to 15 liters per second. The number of fire pump adapters provided for each type of water extinguishing system should be determined through calculation based on the system's design flow rate, but when the calculated quantity exceeds 3, it can be appropriately reduced based on the reliability of water supply. When a temporary high-pressure fire water supply system provides water to multiple buildings, fire pump adapters should be set up nearby each building. When the fire water supply is vertically zoned, pump couplers should be installed in each zone within the pressure range of the fire truck's water supply. If the building height exceeds the water supply height of the fire truck, the fire water supply should have a suction port and pressurization interface for hand pumps or mobile pumps to relay water supply at locations such as equipment floors that are convenient for operation. The pump coupler should be located outdoors where it is easy for fire trucks to use, and the distance from outdoor fire hydrants or fire water pools should not be less than 15 meters and not more than 40 meters. The installation height of wall-mounted fire pump couplers should be about 0.70 meters from the ground. The clear distance from doors, windows, holes, and openings on the wall should not be less than 2.0 meters, and they should not be installed under glass curtain walls. For underground fire pump couplers, the installation should ensure that the distance between the water inlet and the bottom of the well cover is no more than 0.4 meters, and no less than the radius of the well cover. Through learning, we have understood the design and setup requirements of commonly used equipment for fire water supply and drainage. In our next lesson, we will explore the components and classifications of fire water supply systems.